Okay, I'm looking at 2022 paper 2 question 3 and we're talking about coordinate geometry of the circle. You're given the equation of a circle except that the constant at the end is k. And we're told that the radius of the circle is 5 root 3. We're asked to use this information to find the value of k. If you go to your maths tables, you'll see the formula for working out the radius is it's the square root of g squared plus f squared minus c. Remember that the coefficient of x represents 2g, so if 2g is equal to minus 2, I can say that g is equal to minus 1. The coefficient of y is 8 here, and that's 2f, so 2f equals 8, which means f is equal to 4. And the constant at the end from this formula represents the c, so the c in this case is equal to k. The question told me the radius is 5 root 3. In other words, look at the formula in your maths tables, you know what r is, you know what g is, you know what f is. The only thing you don't know is c, so you simply sub in. If I sub into this, I get 5 root 3 equals the square root of minus 1 squared plus 4 squared minus k. And if you add those numbers together, you get 17. What I decided to do then was to square both sides to get rid of my surds. 5 root 3 squared is 75, and if you square the right, then this square root just cancels. Then all I did was bring my k's to one side, my numbers to the other side, and you end up with k equals minus 58. Okay, in part B, we're given the equation of a circle, and we're told that there is a line that's a tangent to this circle at the point 9 minus 4. Remember, we've studied questions where it says at the point or from the point. At the point is the easy one because it means the point is on the line. From the point is the harder one because it means the point is not on the line. But this is relatively straightforward as long as you draw yourself a diagram. Essentially, remember that you can immediately determine the center of this circle. You change the sign of the minus 5 and you change the sign of the 2, and they form the coordinates of the center of the circle. So the center of the circle is 5 minus 2. And I know that there's a tangent at the point 9 minus 4. Now, remember the thing that you know about tangents. A tangent is perpendicular to the radius at the point of contact. So the radius I've drawn here is perpendicular to the tangent. The question is to find the slope of the tangent. So what I'm going to do is find the slope of the radius and then get the perpendicular slope. What I decided to do here was I decided to label this as x1, y1 and this as x2, y2. If I have 2 points on the radius, I can obviously get the slope. If you go to your maths table, your formula is y2 minus y1 over x2 minus x1. I simply subbed in my values and I ended up working out that the slope of the radius is minus a half. Remember that to get the perpendicular slope, you flip the fraction, you invert the fraction and you change the sign. So there's a minus in front of it, which means the slope of the tangent is positive, and instead of 1 over 2, it becomes 2 over 1. So the slope of the radius is minus a half, but my answer, the slope of the tangent, is simply 2. Okay, in the final part of this question, we're looking for the equation of two circles that have the x-axis and the y-axis as a tangent. We know that each of these circles contain the point 1 minus 8. And we can see from the diagram that the two circles are in the fourth quadrant. They're in this quadrant where the x-coordinate is positive and the y-coordinate is negative. So I need you to remember that to get the equation of a circle, you need the center of the circle and you need the radius. So I need to work out what r is, I need to work out what the x-coordinate is and what the y-coordinate is. They're the three things I'm looking for. But I want you to, let's just come up with a hypothetical one here. Let's pretend the radius of this circle is 2. If the radius of the circle was 2, then the distance from here to here is the same. Like the one radius would be from here to here. That's a radius. So that distance would be 2, which obviously would mean that the distance from here to the point of contact would also be 2. In other words, the x-coordinate there is 2. So if the radius of this circle is 2, then the x-coordinate of the center would also have to be 2. Let's consider another radius is that if I draw a line from the x-axis down to the center of the circle. Obviously that distance has to be 2 as well, which means that the y value goes from 0 down 2 units. It would have to be at minus 2, which means that the y value would be minus 2. So in this hypothetical scenario, if the radius of the circle was 2, then the x-coordinate of the center is the same as the radius, and the y-coordinate of the center is minus whatever the radius is. So the point is, we need to find the radius, which we're going to call r. We also need to find the center of each of these circles, and the center of each of these circles, well, the x coordinate will be the same as whatever the radius is, and the y coordinate, I just changed the sign, so it'll be minus r. So I need to work out what's the radius of each of these circles, and then when I get that, I also know the x coordinate, and I also know the y coordinate, and then I can get the center of the circle. So that's the logic you need to follow here. If you get that far, the rest of this is quite straightforward. Every circle can be written in the form x minus h to be squared plus y minus k to be squared equals r squared. So let's sub in the values, let's sub in our r's. If I'm trying to find r here, then I would say the center of both of the circles that have the x-axis and the y-axis as a tangent are x minus r to be squared plus y minus r to be squared equals r squared. Now you'll notice I've a lot less variables, because if I'm looking for the radius, the x value is the same and the y value just change its sign. But also notice, if you know a point on the circle, you can just sub it in. And a point on each of the circles I'm looking for is the point 1 minus 8. So I can just sub in 1 as my x and minus 8 as my y, and then I'll be able to get r. So let's explore that. Instead of x minus r, if I sub in the point that's on the circle, it becomes 1 minus r squared. And instead of y minus r, well, instead of y, I can put in a minus 8. And minus r is the same as plus r. So it becomes minus 8 plus r to be squared. And you let that equal to r squared. Now life is simple. I've got one equation and one unknown. We're just going to multiply this out. It's going to become a quadratic equation which we can factorize and solve. So I just multiplied this out. If you multiply 1 minus r by 1 minus r, you'll get 1 minus 2r plus r squared. If you multiply minus 8 plus r by minus 8 plus r, you'll get 64 minus 16r plus r squared. At this stage, we just have an r squared, an r, and a number. So we've got a quadratic equation. So I just move everything to one side and group my like terms. You get r squared minus 18r plus 65. If you factorize and solve your quadratic, your two possibilities for r are r equals 13 or r equals 5. Now, the question was to get the equation of the two circles. And remember, the first thing we said was, well, if I know the radius, I'll also know the center of the circle. So let's call C1 is the first circle we're going to get. The first scenario is that the radius could be 13. If the radius is 13, then the x-coordinate of the center is also 13, but the y-coordinate of the center is minus 13. So that's our radius and that's our center. We'll use that in a moment to get the equation of our first circle. For the second one, instead of a 13, r is equal to 5. So in the second scenario, we're going to say the radius is equal to 5. And if the radius is 5, the x value is the same, and the y value, you just change its sign, it's minus 5. So if the center and the radius of each of my circles, I can just write down my answer now. So if you go to your maths tables, to get the equation of a circle, it's x minus h squared plus y minus k squared equals r squared. In the first scenario, my h is 13, my k is minus 13, and my r is 13. So your first answer is x minus 13 squared plus y plus 13 squared equals 169. And the second scenario, you sum in your radius is 5 and the center is 5 minus 5, and you end up with x minus 5 squared plus y plus 5 squared equals 25.